All right, now in this video, we're going to go over how to solve a quadratic using the quadratic formula when it's not in standard form. So hopefully you remember what standard form is. Standard form is when it's in y equals ax squared plus bx plus c form. What do you notice about problem 3? It's not an ax squared plus bx plus c form, right? This negative 2 is on the side completely by itself. We don't want that 2 to be by itself. We want that 2 to be with everything else. So how do I move a negative 2 over to the other side? I would add 2 to both sides. So I'm going to end up with a negative 2 and a positive 2 canceling each other out. So I get p squared minus 3p plus 2. When things cancel out, that means they equal 0, right? So that should match now the format of our problems above. So now we can do the same thing. A is the number in front of the p squared, so a is 1. B is the number in front of the p, which is negative 3, and c is 2. So I'm going to use x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, I'm writing the quadratic formula for you every time because that way it makes sense why I'm plugging numbers in where I'm plugging them in. So x equals negative b, but b is a negative 3, so minus a negative, plus or minus negative 3 squared minus 4 times 1 times 2 all over 2 times 1. So I'm just plugging things in for a, b, and c. Okay. Now we want to simplify. Again, you can do this on your calculator or you can do this by hand if you want. Negative 3 squared is 9 minus 8. And what is 9 minus 8? 1. So we have x equals minus a negative just becomes a positive 3 plus or minus the square root of 1 all over 2 times 1, which is just 2. So I know it looks really, really, really complicated at the beginning, but once you're simplifying, it starts looking more manageable. Okay, what is the square root of 1? What multiplies by itself to get us 1? Just 1, right? So this is going to break into 2 separate answers. We get x equals 3 plus 1 over 2, and x equals 3 minus 1 over 2. 3 plus 1 is 4. 4 divided by 2 is 2. 3 minus 1 is 2. 2 divided by 2 is 1. So for problem number 3, our x is equal to 1 or 2. Alrighty, hopefully that makes sense. So the only difference for this problem was we first needed to set it equal to 0 because it equaled negative 2. Okay, moving on to number 4, and I want to remind you, feel free to pause as needed, but moving on to number 4, what's our first step here? We need to move that 5 over to the other side. So it's a positive 5. How do we get rid of it? We subtract it. Now, think about where you need to subtract this from. You're subtracting this from the 6 because those are the like terms here. Those are the terms with no variable with them. So we have 5x squared plus 4x plus 1 equals 0. Let me write my quadratic formula for myself. And even though you don't have to memorize it, you'll probably write it so many times, you'll have it memorized. So our a value here is 5. Our b value here is 4. And our c value here is 1. So we can just plug those in. X equals negative 4 plus or minus the square root of 4 squared minus 4, so many 4s, times 5 because a is 5, times 1 because c is 1, all over 2 times 1. So we took our quadratic formula and we plugged in all of these numbers and for A, B, and C. Okay, now it's time for some simplifying. So 4 squared is 16 minus 20, because 4 times 5 is 20. So we're ending up with x equals negative 4 plus or minus the square root of 16 minus 20 is negative 4 all over 2. Can we simplify the square root of negative 4? Think back to what we learned in 9.3. Can you take the square root of a negative number? No, you cannot. So what do you think the answer is here? No solution. Now you might be slightly confused because what I said earlier was the quadratic formula solves every single quadratic. Not all quadratics cross our x-axis. We could be more exact in our answer if we use, and I mentioned this in a different video, but the square root of negative 1, if we call that an imaginary number, we can simplify even further. But that is not an Algebra 1 topic that we're going to discuss this year. So for this problem, anytime you get the square root of a negative number, your answer is no solution.